When you have an object and it's in motion, it has kinetic energy. The equation for kinetic energy is this. Kinetic energy is equal to 1 over 2 mass times velocity squared. The net work done on an object can be written as the change in kinetic energy. This means the final kinetic energy minus the initial kinetic energy. This can be written as the value of the second kinetic energy minus the value of the first kinetic energy. And this right here is a very, very important principle. It's called the work energy principle or the work energy theorem. What it's saying is that the net work done on an object is equal to the change in kinetic energy of that object. So we know that work and kinetic energy are closely related. That means the more work being done in total, the more kinetic energy will increase. If that was a little confusing, let's go through an example. Let's say you have a punching bag. A boxer here, he punches the punching bag with his punching glove. When he punches the bag gets pushed back. And this displacement we'll label with D. The force is acting on the punching bag when he hits it. There's of course the force acting on the bag, and because of Newton's third law, a force gets exerted back on the guy's hand. So this would be a positive force and this would be a negative force. Now the net force being applied to this guy's fist is going to the left, but the displacement of the punching bag is going to the right. So that means the net work being done is equal to FD cosine 180, because this is 180 degrees. This simplifies to negative FD. Now because net work and kinetic energy are connected, if the work being done on the fist is negative, what happens to the kinetic energy? The kinetic energy of this glove decreases when you hit the bag, and that's usually to 0, which means your hand is stopped. And by the way, kinetic energy, just like work, is also measured in joules. Let's go through a proper problem. Let's say you have a 1500 kilo truck and you want to accelerate from 0 meters per second to 30 meters per second. What's the net amount of work required to perform this change in velocity? In a truck, there's a lot going on. There's the engine, the wheels, the friction, but we're going to ignore all that. We're just going to imagine the car as a simple object in our solving. So we know that net work being done is equal to the change in kinetic energy. And the change in kinetic energy is written as this. All we have to do now is simply plug in our values and we can see how much the kinetic energy changes. And before we plug in our values, I'm going to explain to you why we would use this over the other general work formula. Right here we're given two values, mass and velocity. If we wanted to use this equation, work is equal to force times displacement, we would have to find the force being done and the displacement, which is extra steps. In this specific situation, it's simpler to use this formula because we're given the mass and velocity at 2 points. So they do the same thing, but you make a selection based on the problem that you're trying to solve. I'll plug in the values now. And you get 675,000 joules of work being done on this truck to accelerate it to 30 meters per second from rest. In scientific notation, this would be 6.75 times 10 to the power of 5 joules. Scientific notation is useful when it comes to work because a lot of the time you get big numbers like this. If you're already in the hundreds of thousands for accelerating a truck, imagine how much force you need to launch a rocket. By the way, something that really helps me is having all the formulas you ever need in one place. And I make these cheat sheets for myself, and if you want your own, it's in the description for free. So go sign up.